Hello 108 class, Mr. McHugh here with you. We're going to pick up from our last example 4. We're on page, section 9.6, page 5. And I basically did this on the last video, but here's the nitty-gritty detail of graphing that problem from before. And the only thing I might want to add is, let me go get some color here. That line of symmetry was at 1/2. There's your LOS, and guess what it would be equal to? Who can help me out? Okay, you're crossing what axis? Oh boy, look at the label my XY axis. Yay. I have an algebra teacher would take off 2 points for that. X equals what? Where does it cross the x-axis at? 1/2. Okay, so you found the vertex. You need that. You found the roots. Notice 3, 0, -2, 0, and we found where it crossed the y-axis. It was what? 0, -6. Kind of like the y-intercept from y equals mx plus b, but nothing to do with linear equations, just that it crossed the y-axis. Okay, so between all of those you could graph them. What's the bottom line from MyMathLab? You have to put the vertex. You have to pick one point on the right-hand side, okay, and then you confirm that it matches the other one. Or down here. I don't know if I would do this one or not since it's so close, but okay, so that's the idea. So let's move on here. Objective 3, we are looking at using the discriminant to determine the number of intercepts on the vertical parabola where it crosses the x-axis. Okay, now I think I've been talking about this. This is from chapter 8. 8.7. Now this is where I'd recommend you go back, use your class notes, look at those complex numbers, and we were talking about the discriminant was b squared minus 4ac. Again, you know, this is coming from when x equals the standard form of the quadratic equation. Excuse me. Why did I put x there? I'm losing my mind. 0 equals ax squared plus bx plus c. Remember, that 0 there, that's the y, or that's the f of x in there. When we set that equal to 0, that's where it's going to cross the x-axis when y equals 0. Does everybody see that? Okay. So now the discriminant was underneath the radical, and that was because based on the result of before you take the square root, and I like to put the radical sign on it. Remember that? You have 3 cases. You can have a case A where you take the square root and it turns out to be a negative. Square root of a negative number is a imaginary number. Okay, you can luck out and get b squared minus 4ac all equal to 0. When you take the square root of 0 plus or minus, you still get 0. That's just one solution. Over here, if you happen to have a positive number, where this happened to be a perfect square root to make it easy, you have what? 2 solutions, just like we did up here where you're going to cross the x-axis. Okay, so the cases are this. I kind of summarized these here. This is what's going on here is, let's just say you have a friend, he's working on a physics experiment, and he knows he's dealing with a quadratic equation, and he just wants to know how many solutions he has. He doesn't care where they are, and he wants to know, he has this crazy complex equation. Could you help him out by using in your toolbox b squared minus 4ac, figure out that, do that calculation, and then based on whether it's a negative, a 0, or a positive, you could tell them where it's going to cross the x-axis. Here, none. This is step A, no intercept. Here's an examples. It's above or below. These are just parabolas opening up or opening down. One intercept means it touches somewhere right on the x-axis one time, up or down. Finally, 2 intercepts. This is what we usually think of a lot, and that's because the quadratic, and you know, you got the reverse FOIL and factoring. We see this a lot. Okay, of course here's the vertexes for these guys too. Okay, so next page we're going to do some examples there where you're going to help your friend, help them determine how many times it's going to cross the x-axis or how many solutions there are. Okay, so for now, Mr. McHugh, I think we have done pretty good on this page, not too bad, so we're going to give ourselves a check on here. And page 6, like I mentioned, we're going to go through and run through an example of calculating the discriminant b squared minus 4ac based on that result, helping out your friend, telling how many solutions you have. Okay, so for now, Mr. McHugh, I'm going to say goodbye, and I'll see you for page 6. Okay, take care.